Okay, so go ahead and Jess, you want to bring up that I think it's easier for you to share a screen than Gonzalo, if I remember. Okay, so you were wondering about question 2. Do you want me to go over question 1 really quick just to make sure? Did you get that one right?
I got half of it right. I realized my mistake for the, I'm pretty sure I got the angular momentum wrong.
Okay, so the first one is just I omega.
Correct.
Right? And then the second one is 1/2 I omega squared.
Correct. Yep.
And then the question is, looking at these, what were your particular, can you scroll up a little bit more? What was your omega initial? Didn't you get like an omega initial and an alpha? And so the question is, if omega initial is -1 and alpha is 2, okay. Oh, whoops, I misread that one. Oh, it's initially at rest. So for yours is initially at rest, and alpha is -1. Sorry about that. I misread it. That's how that stuff happens, right? And so this one is going to have a I omega is a vector, and that's where we got to think about the negative slope, right? You got it? So I would see this in this particular case, that's the angular momentum. Do you agree? Because it starts, do you agree I is just a constant? And if I is a constant and omega starts at 0, we know it has to start at 0. So that immediately eliminates this one, and 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 this one. So now we're down to these. And then the idea is, because it depends on omega linearly and alpha is a constant, I know that omega final equals alpha t, because omega initial is 0. You would get some kind of straight line motion.
Yeah, I put the r squared into it, and that's what kind of confused me. That's why I chose 4 for it, because I was thinking it was going to go down exponentially a bit more, but no, it's staying the same. So, and then I saw it at the end.
I got you. Some people had omega naught equals some number, and then alpha was also some number, but it was negative. And in those cases, maybe you would get a line that looks like 9 or 10, depending on whether it was positive or negative. And then energy, you got to remember to square it. So it sounds like you remembered that.
Yeah, that's the one. That's the number 3.
Right. So. Whereas if you were one of those people that had something non-zero, you might have gotten something like 7 or 8, right? Because yours would go to 0 in the middle. So it's basically a parabola. All right. Enough said on question 1. Let's go to the 2, which you cared about. Oh. Okay, I got it. A rod. Go ahead.
Yeah, this is the this one. I just couldn't figure out V. Or unless I didn't need to figure out V, then I messed that up.
The trick here was the rod has negligible mass, right?
Correct.
So then in this case, when it gets to the lowest point in the swing, do you agree it falls some distance? I'll call this 2x.
Oh, shit.
Yep. So isn't the velocity in this case, because it's a point mass, you could actually just say V equals the square root of 2g height fallen, which is 2x. Or you could also say it like this. You could say the center of mass is right here, right? So you could say mg height of the center of mass initial equals 1/2 I omega squared plus mg height final. You know what I'm saying?
Oh, sorry. I keep pressing stupid space bar.
That's all right. And when you do that, there's supposed to be a squared there. But then, and what is the moment of inertia for a point mass with a massless rod?
Isn't it mx squared?
Yeah, it's just going to be mx squared, where x is the distance here. And so you could do that to get omega, and then all you have to do is you could either say the final angular momentum is magnitude. Whoops, it's not 1/2. It's either I omega or it's m v x, where x is the radius.
That's what I was trying to do. MVX.
So either way would work in this case. Got it?
That's just the velocity. I'm gonna write that down real fast, just so I remember it.
Yep, you could screenshot that if it helps.
I'm gonna put it in my book, so I have to search for it.
Oh, okay.
That helped me understand a lot.
Yeah. So remember, the idea was you do an energy problem while it swings, and then I wanted, basically, you're supposed to look for angular momentum. That's your clue to think, I need this formula here. If you want to use that formula I omega, well, I need the moment of inertia. And then you look for the rod. You're like, oh, the rod doesn't matter. It makes it so much easier when the rod is massless, right?
Yep.
So that's why I was saying, I'm like, oh man, this problem looks hard, until I saw that the rod had no mass. And then it's an easy problem because the center of mass calculation takes 0 time.
Yep.
And it's the same concept as the harder ones without having to do center mass all over the place. Got it?
Yeah, that was close.
Okay.
No, I should have read it more carefully because then all those other stuff at the top would have, like, I could have just ignored it.
A lot of it, yes. And this, I don't want to lie to you, I am not the only physics teacher that does this. This is actually a very common technique where a physics teacher will give you a bunch of extra information, and the idea is not to torture you, it's to see if you can discern which pieces of information matter. And this is actually a huge life skill, because in the real world, there's infinite amounts of information out there all over the place. And you have to think, what is the information that actually matters to this problem? And that's why we do it, not just to be mean. So if you're wondering why teachers sometimes give you extra information, that is the reasoning.
Yeah, and now it makes sense, because, like, what tripped me up in the problem originally is that I couldn't find a V or even, like, seconds. So I was like, wait, what? Like, what?
Mm-hmm. Yeah, and so this thing's going to swing. And so this is what we did in chapter 10 to do swinging motion with energy. Or you could literally just do simple translational because it was a point mass. I don't know if you remembered, I said only for cases where you have a massless rod with a point mass can you do this shortcut. Now, obviously, I'll mention this just because other people might be watching. The only difference here is if some of these were starting at the right side, the change in height is only x, not 2x. Got it?
Right.
So some of you, if it only fell this far, the distance it falls is actually just x. All right.
So I just want to make sure. So basically it'd be m times the x times the v. Correct? Or would the x be doubled since
either one of these? Okay. Now, no, you should not. So the angular momentum is mass times speed times r perpendicular, where for chapter 11, r perpendicular, I was calling the distance from the pivot to the, so notice for you had to use 2x to get the energy because it falls distance 2x.
Correct.
It falls twice the r perpendicular.
But the r perpendicular is just going to be 0.08. Oh, sorry, 0.0851.
Yeah. Got it?
Yeah. Sweet. I see it. I was close. Okay, sweet.
Okay. And then what's the last one, just for thoroughness? Did you get that one? Oh, didn't have time.
All right. Didn't have time.
How would you do this one?
So this kind of reminds me of that bullet problem.
Yes.
11.1 over 11 point nasty.
Except all we had to do is get angular momentum of the point mass. So now you have to get, so one thing you could do you agree we could get this distance?
Hold on. Yes.
X squared plus y squared or something, square root. Now, in this case, we've got this thing going here at some speed, and I know this angle, we're told this angle is Q. Do you believe that you could get this angle in here that I'm going to draw in just a second? Do you believe you could get this angle I've shown with the double bar in mustard color?
Yeah.
Because again, we know X and we know Y. You should be able to get the angle from some kind of inverse tangent.
Yeah, should. Oh.
Do you agree that this is also the same angle?
Yes.
And I'll just call that phi for right now. Give me a second. So if you know the angle phi, right? So phi is going to relate to tan inverse, I think, of in this problem for x over y. You could actually just get the angular momentum by doing m v r sine of some angle. I'll call that theta. Theta is the angle between the velocity vector and the radius vector, which in this case, I believe is q plus phi.
Okay.
Does that help?
Yes.
Gonzalo, you good?
Well, actually, my number 3 was different. So
yeah, but it's the same principle probably. And we could look at your number 3 in just a second. You might have had what was yours? Was it a plate or what was it?
Well, it was the same, except it was the ball was hitting it at a different angle from a different point.
Right. And so the procedure you would follow is do geometry, and yours might have been phi equals q minus, or maybe your theta was q minus phi, or maybe it was q plus phi, and phi was calculated tangent inverse of y over x. But depending on where you shoot this thing, so if you do the same problem here like this, and let's say you shoot it this way at a different angle like this. Give me a second. Let's say I asked you for this angle was Q, right? Well, then you'd have to do some more geometry here and say, well, if that angle's Q, this angle's Q, and then this angle would be 90 minus Q, right? So you might have to do something like that. And then again, you could also have the distance here. This would be R, and so maybe this is Y, and this is X here. So it'd be something similar, and you could still figure out this angle here. It might not be the same as that other picture, but then you could say for you, it looks like in this problem, it might have been theta could be 90 minus Q plus phi. So depending on how you had to work this thing out, it might look something like that. Is that okay?
Yes.
All right. So that's how you could do that. I'm going to go ahead and stop the live stream if that's okay. Unless, wait, any questions before I stop it?
No.
Talitha?
No, I'm good. Thank you.
And Jesse?
I am good and fried.
Okay. And then what about you, Christian?
I'm good on that.
Okay. How about you, Phil? You got all that?
No, I'm following. No worries. That sounds good.
All right. I'm stopping the live stream.